This is an introductory video outlining the generation and features of an AC sine wave. With Westinghouse and Tesla winning the battle for the AC electricity, it opened the opportunity for its many uses. A perfect example is the powering of lights, speakers, and instruments at its AC-DC concert. Now you might ask how this electricity is generated. It starts by turning mechanical energy into electrical energy. This is done by rotating a conductive coil through a magnetic field. The coil cuts through the magnetic flux lines and we see a voltage throughout the coil. The polarity of the voltage changes as the coil continues to rotate past the points of equilibrium. This oscillating process creates an AC current. This process is transposed to a linear form. The diagram illustrates the derivative of the vertical projection of the vector rotating in a circular motion. The maximum point of the circle is proportional to the maximum voltage of the wave. The components of an AC sine wave are peaks and troughs indicating maximum and minimum voltages of the wave, peak-to-peak voltage, which is the measure from peak to trough, the wavelength, which is the distance between two consecutive peaks, equilibrium, where the wave balances out and measures a voltage of 0, amplitude, a measure from the peak voltage to the equilibrium, period, the time it takes for the wave to complete one oscillation. The frequency can also be translated from the period simply by taking the inverse of the period value. RMS, or the root mean square value, gives the DC voltage equivalent. The x-axis measures time, the y-axis measures voltage, and finally the phase angle, which indicates the distance of the wave to the origin. If the wave cuts before the y-axis, the angle is positive and said to be leading, while conversely, if the wave passes after the y-axis, the angle is said to be lagging and given a negative value. The mathematical equation for an AC sine wave can be denoted as A, the amplitude of the wave, omega, which is the value equal to 2 times pi over t, where t is the period. Theta either can be positive or negative and represents the angle. T, which is the variable of time. Here is an example of an AC sine wave. It is the voltage recorded from Angus Young's guitar. The question asks us to calculate the mathematical formula of the wave. We start by finding the value of the amplitude, which is illustrated to be 240 volts. Omega is found by dividing the period of 0.02 by 2 times pi, equaling 314. Theta is said to be leading by 30 degrees in this waveform. Now we simply pour it back into the general formula, giving us 240 sine 314t plus 30 degrees. Thank you all for watching.